Eccentex was selected for Round 2 of DIU Project Spectrum Strike to demonstrate a faster, more controlled operating model for Spectrum mission authorization. Today, the process is often manual, document-heavy, and sequential. Requests move across forms, reviews, technical analysis, and approvals with limited end-to-end visibility. The Eccentex app-based platform brings this process into one governed operating environment, combining dynamic case management, low-code configuration, AI-assisted triage, intelligent document processing, RF modeling, and business intelligence. The platform's fully configurable architecture enables agencies to rapidly adapt new workflows, forms, and business rules without custom development, allowing the solution to evolve as mission requirements change. In this demonstration, we show the end-to-end Spectrum authorization process, from portal submission through document data extraction, RF modeling, case management, human review, and playbook creation with leadership visibility. The portal experience begins on a clean, intuitive homepage designed with one primary goal: simplicity. For the purposes of this demonstration, we've pre-populated many of the fields so we can focus on the end-to-end workflow rather than manual data entry. Step 1 captures the request type, priority, allocation stage, and operational requirement. Step 2 captures the required DoD general information, including the classification, requesting organization, requester, program manager, application title, system nomenclature, and technical point of contact. Step 3 documents the mission purpose and operational concept, describing how the Spectrum will be used, the operational need, and the expected mission impact. Step 4 captures the geographic operating environment. For this demonstration, the request is centered at Will Rogers State Park Road in Pacific Palisades, where the operating area, latitude, longitude, operating radius, altitude, and participating units are recorded to support downstream RF propagation analysis. Step 5 captures the technical spectrum information, including the 600 to 2,800 MHz frequency band, preferred operating frequency, bandwidth, transmitter, receiver, and antenna characteristics. Equipment details, operating parameters, and antenna specifications are recorded as part of the authorization package. Step 6 allows the requester to upload supporting documentation. Once uploaded, the Intelligent Document Processing Engine automatically extracts key information from each document, which will be presented later in the demo. Step 7 presents a complete DD Form 1494 readiness review. Here, the requester reviews the data extracted by the Intelligent Document Processing Engine alongside the information entered through the portal. Required fields are automatically validated, completed sections are identified, items requiring additional review are highlighted, supporting documents are verified, and the requester electronically certifies the submission. Once submitted, the portal generates a unique tracking number and automatically creates a managed Spectrum authorization case for intake validation. The requester can monitor the request from the My Submitted Requests page, where they can view real-time status, assigned reviewers, service level targets, and the progress of the authorization through intake, MILDEP review, NTIA/IRAC coordination, and final approval. Earlier in the demo, we submitted a Spectrum request through the portal and uploaded the supporting documentation. Intelligent document processing is built directly into a Eccentex app base and embedded within the end-to-end Spectrum process. Documents can enter through multiple channels, including the portal, email, fax, or other submission methods. As documents enter the workflow, AppBase classifies them, extracts key information using AI, and presents the results for human verification before the data moves downstream, and can reduce data entry time by 90%. Our first document is the SLP4G-LTE antenna datasheet. AppBase has automatically recognized the document type and extracted more than 40 technical attributes, including frequency range, antenna type, gain, polarization, beam width, impedance, dimensions, and other engineering specifications. Notice the confidence scores on the right. Most fields are green, indicating high confidence. A few are yellow or red, allowing the reviewer to focus only on information that requires attention instead of reviewing every value manually. When I select any field, AppBase highlights its exact location in the original document, allowing the reviewer to verify or correct the value in seconds. This human-in-the-loop model combines AI speed with analyst oversight, ensuring trusted data before it enters the Spectrum authorization process. Next, we process a handwritten document, D1494 form. Using OCR and AI, AppBase recognizes handwritten text, extracts relevant information, and flags any fields that require reviewer attention. Once approved, information from all three document types becomes trusted, structured data that immediately drives the next step of the Spectrum authorization workflow, reducing manual effort, accelerating mission execution, and maintaining human oversight and full auditability. Now let's look at the operational backbone of the solution. Eccentex AI-powered dynamic case management. Every Spectrum authorization becomes a single mission case, bringing together intake data, documents, AI review, RF analysis, approvals, tasks, and the complete audit trail. Instead of managing requests through disconnected emails, spreadsheets, and manual handoffs, the platform orchestrates the full end-to-end authorization process. Now let's switch to the live application. We are now inside the Spectrum management application. The platform uses role-based security, so each user only sees the missions, data, and actions appropriate for their role. On the left is the navigation menu, providing access to dashboards, enterprise case search, submitted requests, authorizations, playbooks, and audit history. If a reviewer needs to locate a mission, they can use case search to quickly find requests by request number, mission, organization, location, frequency band, status, or date range. We begin on My Dashboard, where reviewers can monitor real-time KPIs, assigned work, high-priority requests, and active Spectrum authorization cases. Let's open an active mission request. This opens the Case 360 workspace, the central record for the mission authorization. At the top, reviewers immediately see the case status, priority, assigned organization, requested frequency band, risk level, AI completeness score, and potential conflicts. The workflow shows exactly where the request is in the lifecycle, from portal submission through review, technical analysis, and final approval. The tabs organize the complete mission record. Overview summarizes the case. Requester, mission, location, frequency, and equipment capture the operational and technical details submitted through the portal. DD-Form presents the structured DD-Form 1494 data. Documents stores all supporting files submitted with the request. From this screen, reviewers can also generate standardized documents using configurable templates such as DD-Form summaries, technical review packages, coordination letters, and authorization decision memos, ensuring consistent documentation throughout the authorization process. AI triage highlights completeness checks, confidence scores, and recommendations. Deconfliction displays RF conflict analysis and engineering results. Reviews captures reviewer comments and collaboration across organizations. Under More, reviewers can access approvals, communications, tasks, generated authorizations, playbooks, and audit history. For this demonstration, we'll open Approval. The reviewer has all of the decision context in one place and can move the request forward with a single action. I'll click Approve. The workflow advances automatically, the case status is updated, the approval is recorded, and the next reviewer is notified. Let's verify the decision. Every action is automatically captured in the audit trail, recording who performed the action, what changed, and when it occurred. This provides complete traceability for every authorization decision. The mission case now contains the complete operational record, from submission and document generation through review and approval. Next, we'll move into RF modeling to see how propagation modeling, interference analysis, and engineering recommendations are performed and then integrated directly back into the mission case to support the final spectrum authorization decision. The proposed technology offers RF modeling service that integrates empirical algorithms with physics-based models to simulate radio frequency propagation and interference. The service serves as a wrapper around third-party libraries such as Cloud RF, CovLib, OpenEMS, which implement various propagation models. This allows engineers to choose the model that best fits the specific operating environment. High-fidelity modeling relies on input data from DD Form 1494, as well as supplementary documents, terrain elevation data, land clutter or land use data, and atmospheric parameters. The output data from the modeling process consists of quantifiable, simulated metrics that describe how electromagnetic waves travel through a specific environment. This data is stored as geographical polygons in the system database. Now, let's look at Eccentex Business Intelligence. Eccentex BI provides real-time operational dashboards that give executives, managers, and analysts immediate visibility into the entire spectrum authorization process. At the top, we see key performance indicators, including open cases, pending RF actions, urgent requests, active authorizations, AI confidence, and policy exceptions. Below that, interactive dashboards provide mission location maps, AI recommendations, case details, aging analysis, deconfliction trends, reviewer workload, mission readiness, executive summaries, and SLA compliance. Every chart is interactive, allowing users to filter, drill down, and navigate directly into the underlying cases. To demonstrate the platform's flexibility, I'll open the Dashboard Designer. With a no-code interface, administrators can modify existing dashboards, change chart types, add filters, rearrange widgets, or create entirely new dashboards from available data without writing code. This enables every organization to build dashboards tailored to its own mission, KPIs, operational priorities, and executive reporting requirements. Now, I'll briefly demonstrate the power of the Eccentex App-Based Low-Code Designer. App-Base enables authorized administrators to configure the application without custom coding, allowing the solution to adapt quickly as mission requirements evolve. We begin with security and organization management, where administrators configure users, business roles, permissions, and the organizational hierarchy. Next, we open the DD Spectrum Authorization case type, where the business process is defined, including milestones and workflow logic. The data model defines the business objects and fields used throughout the application. New fields can be added without changing application code. In the Workflow Designer, I'll quickly add an email action to demonstrate drag-and-drop business automation. In the Form Builder, I can place those fields directly onto the form and adjust the layout with drag and drop. We demonstrated how the Eccentex AI-powered, low-code, app-based platform transforms Spectrum mission authorization into a faster, AI-assisted, fully configurable end-to-end operating model. The platform connects mission intake, AI-assisted document extraction, dynamic case management, RF-informed technical review, human decision-making, dashboards, reporting, and full auditability in one controlled process. The mission impact is clear. Reduce authorization timelines from months to days, improve accuracy, keep Spectrum managers in control, increase transparency, and adapt rapidly as mission and policy requirements evolve.